So hello viewers and welcome back to another video on networking. So in last video of our networking video series, we have seen this you can say introduction session of what is NAT and what is PAT. We have seen these three topics. We have seen the introduction, we have seen about netting, and we have seen about PATing. So if we just briefly go through NAT, so we have seen the concept of public IP address and private IP address, and we have seen what is NAT. NAT is basically translation of IP address, and PAT is basically translation of pair of the IP address and the port number. So now in today's video we are going to see the simulation in CPT. So without wasting much time, let's get started. So we are inside Cisco Packet Tracer, and this is our setup. So as you can see on the screen, we have one router over here, two switches, one server, and two end devices. Now you can see both the server and the end devices are in different network. So the fast Ethernet 0/0, the interface of this router is connected to this end of the switch, which has two end devices. And now we can consider this device as this network as a private network. You can see the IP address is in use, the subnet mask which is in use over here, which is 192.168.10.0/24. That is the private IP address. And for this interface, we have used 10.1/24. For this side, we have taken the public IP address, so 10.10.100.0/24. And the subnet mask or the IP address for this interface is 10.10.100.1/24. Now the scenario is we have this website server over internet, and this is our private network. So and these devices have this interface, these IP addresses 10.2 and 10.3, which means 192.168.10.2/24 and 10.3/24. And both of these devices have been configured with the default gateway of 10.1. Now that is the basic setup. And for this server, the default gateway is 10.10.100.1, and the IP address of this server is 100.2. Now the setup is, so right now if we just ping over here, which should be successful. Okay, the first request is failed. Yeah, you can see the successful messages. Now we can ping from this laptop to this server, and you can see those all are successful. Now we can just go inside the simulation, and we can just see the packet, observe the packets. So by default the packets will be ICMP packets, right? And you can see the source IP is 10.2 and the destination IP is 100.20, which is this server IP address. Now we can see when this packet will reach to this router, you can see the source IP is 10.2 and the destination IP is 100.20, and the outbound packet carries the same IP address, which means our private IP addresses are not translated as of now. And when the server will receive the packet, as you can see, the source IP is 10.2 and the destination is 100.20, which is the server's IP address. But in outbound, you can see the server source IP and the destination IP are changed. You can see 100.20 and destination IP is 10.2. Now we can delete this. Now what we need to do is we need to configure NAT. Now in Cisco we have three types of NAT. The first is static NAT, dynamic NAT, and there is something called PAT. So in this video we'll cover the static NAT, and basically we need to configure static NAT over here in such a way that this single IP address will be mapped to one single public IP address. So that is static pair of mapping, which means we are statically just one private IP will be mapped to one public IP. That's the basic static mapping. So we will configure using the CLI of or you can say on this router. So this is the show running config of current running configuration for this router. Now let's see what happens, how we can configure the static NAT. So To configure this static NAT, we just need to remember one command, or you can say we just need to use one command. So you can just go inside the router 0 CLI mode. We need to go under the global configuration mode, which is called so from this user executable mode we can just enter configure terminal, and then we'll be inside the global configuration mode. Now over here what we need to do is we need to define, so the interfaces of this router are configured, and we can verify that by exit and show IP interfaces brief, right? As you can see, fast Ethernet 0/0 has been assigned 192.168.10.1 and 0/1 is assigned 10.10.100.1. Now we can again enter the global configuration mode. Now we need to just provide the static mapping, right? So we need to configure static NAT. Now for that we just need to use one command, which is IP NAT. Then we can enter the question mark. You can see IP NAT inside, outside and pool. We have three options. So you can see you can just choose the correct option, and as you can see, if you enter inside, that means inside address translation. So we need to do that. And there is something called outside. So that means if there are packets coming into the private network, so those also can be translated. So for that we need to use outside. But right now, and also the third option is to define a pool of addresses. But right now we are just mapping the static mapping, the static NAT configuration. So we will use inside. So IP NAT inside, and we can again enter the question mark. Now you can see we need to we just have one option, which is source, and what it does, it provides the source address translation. So let's use the source. Now question mark. As you can see, we can provide the list and we can provide the static mapping. So we are not using the list, we are providing the static mapping. So let's use static. And now there are, if you enter the question mark, there are three options. The first is to provide the single static IP address, and then there are two protocols, TCP and UDP. So these are like application specific protocols, so we don't need to worry about that right now. What we can do is, so this TCP and UDP are specifically if let's say there is a TCP traffic and there is a UDP traffic, only then the translation rule will be working in place. But if we just provide the static IP address, then it will work on both TCP type of traffic and UDP type of traffic. So now let's just provide the static mapping. So we need to convert this IP address 10.2. So let's provide 192.168.10.2, and after that inside global IP address, which means what private IP address that we want this address to be translated to. Now since this public addresses that we have taken over here, the public IP address subnet is 10.10.100.0/24. So what we will do is we will just configure 10.10.100.2, right? And now we can just enter this, and that's how we can configure the static mapping. Now apart from this, we need to do two more things. For this router, we need to tell this router that what is the inside, what interface connects the what interface is connected to inside of the net, and what interface is connected to outside of the net, which means which interface is connected to private address and which private network, and which interface is connected to public address. So now how can we do that? So we need to enter the interface. So let's first configure this fast Ethernet 0/0. Now this interface is connected to private address or private network. So over here we can give IP NAT inside. That is the command, and that command will let the router know that fast Ethernet 0/0 interface is connected to private network. Now we can go exit, we can enter interface FA0/1, and this interface is connected to outside of the network, which means public network. So IP net outside, and that is it. We can just observe the show running. So you can see IP net inside, IP net outside, and this is the static translation rule. Now this rule will only translate when this device is making a request. When this device is making a request, the IP address, the private IP address, will not be translated. That is why it is static NAT. So now we can test that by just entering the simulation mode. We'll enter one packet here, and then we will enter one packet from this device. Now we will see. So this packet is coming from 192.168.10.2, which is this PC0, and the destination is the server, which means 10.10.100.20. Now outbound, you can observe the source IP is translated to 10.10.100.2, and the destination is 10.10.100.20. So you can see the NAT rule that we have used, that is working. And you can also observe the you can say OSI model. You can see the steps over here. The device looks up the destination IP address in the CEF table, which means the MAC table, routing table. And you can see the NAT rule implemented over here. So the packet is going from an inside to an outside network, right? And the device looks up with the NAT table for the necessary translations. The NAT table has a matched static entry for the source local address, and the device translates the packet from the local to global address. And that is how NAT works. We can also observe the NAT table like this, and as you can see, protocol ICMP, inside global IP is 10.10.100.2:4, which is mapped to 192.168.10.2:4, and these are the what you can say outside global IP addresses. And now we can test for this packet. So this packet is coming from laptop 0. As you can see, inbound is 192.168.10.3, which is this laptop, and the outbound destination IP is 10.10.100.20, which is this server. But outbound, it is also same. There is no NAT translation. There is no NAT translation in place. We just had a static mapping for this 10.2, 192.168.10.2. So now while the packets are translated back, coming back, you can see so this is like so this is ARP packet. So since this server won't have the MAC address for the IP address 10.10.100.2, that's why this is the ICMP packet. You can observe that the source IP is this and the target IP is 10.10.100.2. So this server is asking for the MAC address of the 10.10.100.2, and in reply this router will reply with the MAC address of this interface FA0/1, and you can see the MAC address is 00D0, which is, you can observe here, ARP table, not ARP table, just ARP table only. So you can see 00D0, that is fast Ethernet 0/1, which means this interface. So this ARP packet got back, and meanwhile you can see this packet reached over here, which was sourced from 192.168.10.3, and it was ICMP request to the server, and the reply got the reply with the source IP of 100.20, which is the IP address of this server, and the destination IP is the private IP of this. And now you can see this packet is coming. So this packet, you can see the source IP is 100.2 and the destination IP is 100.2, 20 and 2. Both are from 10.10.100.0/24, network, and you can see the destination IP is changed from 10.10.100.2 to 192.168.10.2. And how this happened? So you can observe over here. So you can observe over here on the layer 3. So the NAT table has a matched dynamic entry for the source and destination global address. The device translates the packet from the global to local address. So now if you observe the NAT table, now if you observe the NAT table, you can see you still have the entry. But once this packet goes from this router to this switch, now if we observe, you can see it still has the IP address, but after some time the timer will expire and this ICMP protocol entry will be removed. So this device got the reply, and now if we enter the real time, if we now observe the NAT table, okay, it still has the entry. I think the timer is not expired yet. So that's how the static translation works, static NAT translation works. So I hope you have got the idea about how the static NAT works in the picture. Now in the next video we will take the same topology and we will configure the dynamic NAT and followed by the PAT. So in this video, that's it for today. I hope you have got the idea about how you can configure the static NATing inside Cisco devices. We'll meet in the next one. Till then, keep learning and keep exploring.